Hello, my dear students. Welcome to our chemistry class. And here is one of the most important topics in the history of chemistry, which is Avogadro's number and molar conversions. We can summarize this topic in the most important word, which is mole. This topic is mainly discussing the meaning of the word mole and what is meant by mole and what is the purpose of making this unit. How can we calculate a mole? What is the relation between mole and other units of measurements? Let's start section 7.1 and let's discuss and study together what is the meaning of mole and how can we calculate it. First of all, let me ask you a very important and simple question. Suppose that we have a lab session and we have visited the lab and we need to make a chemical reaction between sodium and chlorine in the lab, but we do we will do this experiment or this reaction practically in the lab. All of us know that the reaction between sodium and chlorine will produce sodium chloride, which is table salt. But here we will open another point of view about studying chemical reactions. If we need to do this in the lab, let me ask you from this equation, what is the amount of sodium can we get to make the reaction? If you get your information from this reaction, you'll find that sodium here is represented by an atom of sodium. Can you get an atom of sodium practically in the lab? No, it's impossible. What about getting 2 atoms of chlorine in the lab? It's also insane. So what shall we do to do this reaction practically? Chemists made a very important suggestion to make the relation between us and chemistry in the lab more easier. They made a very important measuring unit for chemicals, which is mole. So, first of all, or the first sentence about mole, mole is the measuring unit of chemicals. What do you mean by chemicals? I mean atoms, ions, particles, formula units, and so on. So, if you know that mole is the measuring unit of chemicals, so what should I know about mole? You know that meter is the measuring unit for length, for example, or distance, and we also know that a meter equals 100 centimeters. What about mole? Let me say that mole is the measuring unit of a certain number of particles in an element or in a compound or in an ion or whatever, or a chemical in general. So mole represents a certain number of particles in a chemical. Number of particles in a chemical. What is this number? To know what is this number, let me make it more easier by giving you a very simple example. When I tell you I need a dozen of cards, for example, how many cards you will bring to me? Yes, of course, 12 cards. So a dozen is a unit for a certain number of cards or for anything. The dozen means 12. So mole is also a unit for a certain number of particles of chemicals. But here, we need to know what is this number, or what is the number that represents moles, as we knew now that the number of a dozen is 12. So what is the number of particles which equals mole? A Greek scientist called Avogadro gave us this answer. He said that Avogadro's number is the number of particles in any chemical. We call it Avogadro's number. And this number equals a mole of any chemical. So simply, 1 mole of any substance equals, yes, Avogadro's number. Okay. You mean that Avogadro had calculated this number of particles, which is represented by 1 mole. So it is the same when I say 1 dozen of any substance equals 12 items of this substance. So here, 1 mole of any chemical equals Avogadro's number of this chemical. What is the number of Avogadro? It is 6.022 times 10 to the power of 23. So this is Avogadro's number. Okay? Again, let me say another important thing. And let's turn back to our practical chemical reaction here. If you know that here we will bring 1 mole of sodium, can you calculate the number of atoms of sodium, or the number of particles of sodium that represents a mole? I think it is difficult to. So, how can I calculate a mole practically? Sure, we need a familiar unit you can use, or you can convert mole to this unit. Let's say, for example, grams. Can I convert mole into grams? Yes, we can convert moles into grams. How can we do this? I will give you a very simple example to know about conversion between moles into grams. First of all, you should know that 1 mole equals the number of 12 grams of carbon 12 atoms. Okay? Carbon 12 here means that carbon element which has an atomic mass of 12. So here in this sentence, you can notice that mole equals the number of particles in 12 grams of carbon 12 atoms. So here I can get that we have number of particles, and we have also what? Mass in grams. And that gives us an indication that we can convert mole into number of particles, or we can convert it into grams. First, we have finished conversion of mole into numbers by using Avogadro's number. So what about converting mole into grams? Let me say that example before starting converting a mole into grams. Suppose that you have visited a place here in Egypt, most commonly known as Kidzania. And in this place, you perform a certain job, like an imitation for this job, or you act like that you are working at this job. After finishing your tasks, you get to earn some currency there called Kidzos, right? After finishing your day, you can visit Kidzania's store and you can pick any toy or anything from this store using your currency, which is Kidzos. Let's say that you find a certain toy which equals 10 Kidzos. This toy you will find outside the place of Kidzania in a normal store outside. By the way, you know well that you cannot use Kidzos at any normal store. It is only used in Kidzania, right? But in the normal store, you will find the same toy you have bought from Kidzania, but you found it with equals £1. So now you can make a conversion between the Egyptian pound and the Kidzos, right? You know that the conversion means each £1 equals 10 Kidzos, right? Here in our lesson, we will use the mole to calculate the amount of chemicals that is as it is the measuring unit of chemicals, but we will convert mole into number of particles using Avogadro's number, and we'll convert it into mass and grams using the molar mass of substance. You can deduce from my words that we will use two rules, two mathematical relations will help us to calculate the mole of any substance or any chemical. First, using Avogadro's number, you can calculate the number of moles from this relation. Number of moles equals, let's add this relation. Number of moles equals number of particles of any chemical. And I've mentioned before that particles include atoms, ions, or whatsoever in a chemical. So we'll generalize it in number of particles. Okay. And we will divide the number of particles on Avogadro's number. Okay. Avogadro's number. The relation, or the same mathematical relation in other words, so moles equals number of particles divided by 6.022 times 10 to the power of 23. Okay, to the power of 23. Okay, this is the first rule you can use to calculate moles by the indication of number of particles. The other rule we will use to convert moles into mass and grams is number of moles equals mass and grams. You will be given this info in any problem divided by molar mass of the chemical. And here we have something which is not familiar enough to you, which is molar mass. But it is very simple to know about it. What is the meaning of molar mass? Molar mass is the sum of atomic masses of elements. And you can get the atomic mass from the periodic table. For example, the atomic mass of sodium, you'll find it in the atomic table, in the periodic table, equals 23. For example, oxygen, you'll find it in the periodic table, atomic mass equals 16. And also hydrogen, in the periodic table, atomic mass equals 1. How can I calculate the atomic mass of a compound like NaOH or sodium hydroxide? It is very simple. The atomic mass of sodium hydroxide equals the sum of their atomic masses. So I will sum 23 plus 16 plus 1. So it will give the atomic mass of this compound. Okay? So what if I have, for example, Na2O, which is sodium oxide? I will calculate the atomic mass of each element also and sum them together. But here I have 2 sodium atoms, so 23 will be times 2. Then I will add it to the atomic mass of oxygen. 1 atom of oxygen equals 16, and the total answer will be the atomic mass of this element, of this compound. Okay? So we have finished a very great part in this section. I hope you to study this part well and use this PowerPoint slides to understand what I said, and you'll find it very easy, inshallah. Try to practice on this problem, and you will continue later, inshallah. Thanks for listening, and see you soon.